Good morning, everyone. We are going to give about 2 more minutes because we've got people still coming on. So give us about 2 more minutes and then we'll get started. All right, everyone. Good morning. Thank you for joining us today for 8 reasons why pressure gauges fail with Hardy Orskowski. Before I turn it over to Hardy, I just have a couple of housekeeping things to go over. First, we are recording this session, so I just wanted to let you know that. I also have everyone muted, but if you have any questions or comments for Hardy, just make sure you put them in the chat and I will make sure he gets those and get those answered for you. And that's all I have, so I'm going to turn it over to Hardy.
Good. Thank you, Joni. You guys, can you hear me?
Yep, loud
Joni,
and
can you?
clear.
Okay.
Yep.
So again, good morning, everyone. I hope you're all in a great mood with the weekend just around the corner. Just some more information to my person. My name is Hardy Orzykowski. I am the product manager for mechanical pressure and temperature here at WIKA USA, at the WIKA USA headquarters in Lawrenceville, Georgia. I'm with WIKA for 43 years. And in case you're wondering about my accent, I'm actually from Germany. And I started my career at the WIKA headquarters in Klingenberg, which is a small town located 45 minutes south of Frankfurt. And in 1991, I was able to join the US operation in Lawrenceville just a couple of months after they relocated from Hoboken, New York to Lawrenceville. So as Joni mentioned, today I will be presenting on the 8 reasons why pressure gauges fail. This is a result of basically hundreds of planned audits that WIKA team members have performed over the years, mainly in the process industry. So you might be familiar, some of you might be familiar with the brochure, Why Pressure Gauges Fail. I will drop those links also into the chat after the meeting. I don't want to, after the presentation, because I'm afraid I'll screw the presentation up. So I will, all the links that I'm talking about, I will drop into the chat after the meeting. So this brochure indicates the visible signs and hidden risks. What the brochure does not cover are possible solutions to prevent these failures. Okay, and we also have them blocks. One of the most popular blocks is the 8 common reasons for pressure gauges for pressure gauge failure. This is a block at WIKA USA that has probably the most downloads. It is often being used by people searching for solutions with problems in particular applications, which resulted in another success story, and that's what the second block is about. That was a CEO of a personal care company that contacted WIKA USA regarding problems reading a pressure gauge due to very severe pressure fluctuations and pointer flutter after reading the blog about pressure gauge failures. So he contacted us and we were able to actually provide a solution that helped him in his process. So in this presentation, we're going to cover mechanical vibration, pulsation, extreme pressure cycles, pressure spikes with combined pressure spikes and overpressure, corrosion, temperature, clogging, and the lack of maintenance and improper use. Number one killer of pressure gauges in operations is mechanical vibrations. So what you will notice is high frequency, low amplitude, and erratic pointer movement. It's caused by vibrating equipment near the gauge, usually occurs from pumps or similar reciprocating equipment, and obviously increases the wear and the movement in internal components. And I have a few videos prepared. And you can see how severe what the effect can be if that going on for hours or days. Other signs is a pointer falling off, metal shavings behind the lens. Okay. At one point or one time, we were asked to replace gauges at a Procter & Gamble plant. One of the applications was a conveyor production line producing diapers. Unaware of the actual operating conditions, we replaced the gauges with regular low-pressure capsule gauges. And after they were installed, some gauges failed within a couple of hours. So that's when we actually visited the plant to find out what was going on. The conveyor belt was sitting behind a large plexiglass window. All we had to do is touch the window and we knew what was going on. There was no way a regular gauge would survive those conditions. Okay. These are pictures from actual gauge failures, and you can see the effect that severe vibration will have on the gauge internals, especially on the movement. So you see worn pinion gear, worn segment gear. So that's all a result of the effect that vibration has on the internals. Let's talk about the solution. The solution is case filling. The case filling lubricates and cools all moving parts. It eliminates the pointer flutter. It protects the gauge from environmental ingress. Here you see on the right-hand side an example of what effect you can have from environmental ingress. It prevents fogging, and in combination with a restrictor, it's the best solution also for high pulsation. Another solution is dampened movement. So here at WIKA, we actually have what we call an engineered dampened movement, fully encapsulated disc in a highly viscous media. So you see the picture on the bottom. So we have the pointer shaft is extended through the bottom plate into a shell and attached to a disc. And that disc is fully engaged in heavy-duty silicone, heavy viscous silicone grease, 60,000 centistokes. And here you can actually see the pointer shaft. Okay, so the unique capsule design keeps the dampening media in and the dirt out. It's primarily used to eliminate the pointer flutter from vibration pulsation, and it is recommended for applications where liquid filling is not permissible. So one application, for example, that I was involved with was gauges installed on ship barges operated in the Gulf Coast. So we recommended, of course, a liquid fill gauge, but we were told they cannot install liquid fill gauges because if damaged, they can leak, contaminate the cargo or the environment. And any type of spill must be reported to the Coast Guard. So for this application, we supplied gauges with a dampened movement. Another example would be for oxidizing agents, so like O2 service. You cannot use silicone or glycerin case filling. You could use that very expensive halocarbon oil, but again, it's very expensive. So that would be another example where you can use a dampened movement over a case filling. However, you should not use a dampened movement in very severe applications. As I mentioned, it only reduces or eliminates the pointer flutter. It does not do anything to protect any other moving parts. The damping pot puts excessive load onto the movement, leading to early failure. It accelerates the wear and tear of all internal parts, and it reduces the lifespan of a pressure gauge. So what you see in here in this case, the vibration caused a separation of the link between the Bourdon tube and the movement. So without the anchoring effect, the Bourdon tube continued, of course, to shake violently, eventually resulting in a stress fracture that you see over here. Okay. The next failure mode, extreme pressure cycles, also referred to as pulsations. So compared to vibrations, what you will see is the frequency is normally less than observed in case of vibrations. It's a relatively high amplitude, and it's a very rhythmic pointer movement. And again, I have some videos prepared. Okay. So you can believe me, they're not using a rubber pointer. Here's the next one. Okay, again, it's a frequency is a little bit less than observed in vibrations and a relatively high amplitude. Okay. Solution. The best solution to mitigate pulsations is the use of a internal restrictor or a snubber. So a socket restrictor, it allows pressure to equalize slowly. It's an economical and low-cost solution. The case filling, again, eliminates the pointer flutter, lubricates internal parts, and a restrictor will resolve most pulsation problems, but extreme pulsation, could require accessories like external snubber. We have this one is a piston snubber. We also have adjustable snubbers. So there are different accessories that can be used to mitigate pulsations. Next thing we're going to talk about is pressure spikes over pressure. Pressure spikes, and I have a couple of pictures over there, can be caused by many things, but are usually contributed to turning pumps on and off, and the opening closing of valves. Some pressure gauges exhibit either a bent, broken, or fishtail pointer. Here you see a fishtail pointer. A fishtail pointer is the result of a pointer hitting the stop pin with extreme force. Okay, and again, this is caused by the pointer hitting the stop pin on either negative or positive pressure with such a force that it bends or breaks the pointer. Here you have an example of the pointer broke off. Okay, that phenomenon is also, what that's happening here is also called water hammer. Okay, most of you probably aware about the water hammer. Water hammer is it's like a plumbing shock wave. So when liquid flowing through a pipe is suddenly forced to stop or change direction, like when you open or close a valve quickly, it creates a pressure surge. And that surge can cause loud banging noises, vibrations, or even damage to pipes or equipments. Here some points like sudden valve opening and closing. That's what can cause it. Pump start or stop. Pump power failure. Acoustic wave that moves at the speed of sound in water at 4,700 feet per second. However, you can only have a potential of a water hammer when the fluid is moving about 5 feet per second. And again, it creates an acoustic sound like a hammer beating on a pipe, and that's where the name water hammer is coming from. Okay. The best solution for water or to prevent pressure spikes over pressure is an overpressure protector. Overpressure protector for pressure gauges is a device that automatically blocks or limits the pressure reaching the gauge when it exceeds a safe threshold, and thus preventing damage to the gauge. It is typically set to full scale. It helps maintain accurate readings and extends the gauge lifespan by shielding it from sudden pressure spikes. Okay. Corrosion, another very common reason why gauges fail. You can have, internal corrosion. Let's say the welded parts are not compatible to the media, or you can have environmental ingress, contaminates or moisture getting inside the case reacting with internal components, for example, galvanic corrosion. Galvanic corrosion happens when two different metals touch each other in the presence of an electrolyte like water with salt. And then one of the metals then starts to corrode faster than it normally would. Best solution for corrosion is diaphragm seal, especially if the media is not compatible with a typical bore tube material, which is normally brass or stainless steel. So a diaphragm seal is used in combination with bore tube pressure gauges to protect the gauge from corrosive, viscous, or high temperature process fluids by isolating the sensing element, and it transmits the pressure through a flexible diaphragm that you see over here, flexible diaphragm, and a fill fluid. And it ensures accurate readings while keeping the gauge safe and clean. Okay. So the next failure is high temperature. Okay. Some of the signs: dark liquid, caused by elevated ambient or process temperature, burn marks at the case, you see it over here, discolored dials, and without the use of any accessories, the limitation of the gauges are 100 for ambient temperature is between -40 and 140 degrees Fahrenheit, and process temperatures is up to 140 degrees Fahrenheit for gauges with brass internals and 212 degrees Fahrenheit for stainless steel internals. Now on the right-hand side, you actually see a site that is very common, or is very common site in most processing plants. It's a siphon, a siphon you should use for steam applications. And in this case, siphon is used with a pressure gauge in a steam application, protect the gauge from direct contact with hot steam by trapping cooler condensate inside this coil, which acts as a thermal barrier. But what you see, and that's what I'm getting to, is it's often wrapped in cloth to insulate it. But this contradicts its purpose because the insulation prevents the steam from condensing, keeping the siphon hot, allowing steam to reach the gauge, defeating the protecting cooling effect the siphon is meant to provide. Now, I guess the main purpose is, to prevent injuries. I mean, the siphon is typically very hot, and it's a big device, and so if you touch it, you can easily hurt yourself. Okay. So solutions are diaphragm seal again. For to mount the gauge remotely away from the heat source. Siphons for steam service, and again, only for steam service, not for hot oil or any other hot media, for steam service. Now, an alternative for a traditional siphon is a mini siphon. The mini siphon is a lot more compact. It typically doesn't heat up as much as a siphon, and you have a deflection pipe inside the body that the steam hits the deflection pipe and immediately turns into condensation. Or we have a whole line of mini heat adapters that reduce the temperature to a limitation that can be tolerated by the gauge. Okay. Another reason why gauges fail is clogging. That can be easily observed if there's, it doesn't indicate pressure even though the valve is open and the system is operating. That obviously there's something going on that prevents the media to get into the bore tube. So the socket inlet bore, or referred to orifice, has been obstructed by either highly viscous, crystallizing media, or particles or solids that can clog the orifice and prevent the gauge from reading any pressure. So solutions, again, diaphragm seal, or what we refer to a WIKA seal gauge. It's a diaphragm gauge. It's a mechanical gauge. So the use of a WIKA seal gauge is recommended for low pressure applications that have a chance of clogging due to solids, particles, and viscous or corrosive media. Because, instead of a Bourdon tube, you have now a diaphragm, and the diaphragm is connected to the movement with a push rod. So the media only sees, the lower housing and the diaphragm. Seal gauge is available with female connection. You can have a 3/4 inch or half-inch female connection. You can have an open flange connection. And the membrane and the bottom housing can be supplied with special materials such as Teflon, Hastelloy, Tantalum to be compatible with aggressive media. So that's a really, really good alternative also to diaphragm seal. The last reason why pressure gauges fail that I want to talk about is maintenance, or actually the lack of maintenance in improper use. Yeah, again, a couple of examples. This one gauge was most likely hit by a large heavy object. Here you can see the case is bent, the window is shattered. And another gauge with the window already is broken, and then also this gauge is missing some plugs. So gauges installed or serviced not using the proper tools or damaged by other objects. Visible signs can be broken lenses, cracked or bent cases, and as I mentioned, missing fill plugs and or insufficient case fill. Okay. Solutions is actually common sense. Inspect gauges on a routine basis. Service, repair the gauge at early signs of despair, and then also always use a wrench flat or use the wrench flat to install the gauge. Don't grab it by the case and install it all the way. You can twist it. You can twist the internals and damage the internals. The WIKA XL process gauge is designed to be easily serviced in the field, and we offer spare parts that are actually listed in the operation instruction manual. You can see, I wouldn't recommend to replace a dial, but you can easily replace the back plate, the window, the O-ring, and so on. And that's actually the membrane that comes with the back plate. And that was actually the last reason I want to go over. At the end, I would like to amuse you with a collection of some very scary looking gauges that we found during some of those audits, and I call it the Rocky Horror Gauge Show. And you can see that actually the funny one that comes up over here. Somebody actually put, I have put or draw the pointer on the outside of the gauge. And I mean, you can see, in all honesty, some of the gauges, they are so severely damaged, or you can actually say decomposed, that it's almost impossible to determine the root cause of the failure. Okay. And that's actually the end of my presentation. And we do have time for a couple of questions.
Yeah, Hardy, we do have a couple questions come in.
Okay.
The first one, they said, could you review the advantages of oval versus round board-on tubes, and if WIKA gauges incorporates an oval board-on tube? That's the first one.
Okay, I mean, it's actually, okay, again, it's oval versus round board tube. Well, the shape is determined by the pressure. The higher the pressure, the more round the board tube. The lower the pressure, the more oval the shape is. So it's actually the pressure that determines the shape of the board tube. And the C-shaped board tube goes from, starts at 10 psi. It's the lowest pressure that we can supply with board tube gauges, up to 1,000 psi. Then at 1,500 psi, we are using helical shaped board tubes, and the tube for those board tubes are completely round. So again, the pressure determines the shape of the Borden tube.
Thank you, Hardy.
Mhm.
And the next question is, what is the solution for process conditions where operating pressure is very, very less compared to the design pressure when you select the pressure gauge scale for operating pressure to be within the third of the gauge scale? And if you need to read that again, Hardy, you can click on your chat and it should be the
Okay.
last one.
Okay.
I know that was a lot.
So one, okay. So you basically have to make it high overpressure safe. Um, and one solution is the seal gauge. The seal gauge can be supplied. We have special versions that are high overpressure safe. So you can actually have a scale, 100 over the full scale from 0 to 100 psi. And at the same time, you can make the gauge overpressure safe up to 6,000 psi. So again, you have your regular scale, or it can you can go down to 10 inches of water column and have the gauge overpressure safe up to 6,000 pounds or psi. So that actually would be, you have to make it overpressure safe. And that would be one solution. We have Borden tube gauges that are high overpressure safe. Um, and or again, you can use the overpressure protector as well. And the overpressure protector will be set at the full scale. And once the pressure reaches the full scale, the overpressure protector will prevent any more media to entering the Borden tube.
Thank you. And then we have another question. They would
Okay.
like to know what WIKA's solution is for replacing direct drive gauges.
Liquid filled. Liquid filled gauges.
Li-
Liquid filled gauges would be the solution to replace direct drive gauges. Because
Okay.
direct drive gauges typically were not supplied with case filling, so case filling really is the best solution.
And it looks like the last one right now, Hardy.
Mhm.
Can we repair gauges in-house with some training along with diaphragm seals?
Um, if we have the proper equipment, I know we have a partner distributor that have the equipment. Um, I mean, the easiest what you can do is adjust the 0 point. It doesn't matter if you have now a diaphragm seal or a regular gauge without the diaphragm seal. You can adjust the pointer, put it back to 0 if the pointer is off 0. But you should have a reference gauge. You should have something to compare to a reference gauge to make sure that there's no other reasons. Maybe it was shortly overpressured, and then all you have to do is basically put it back to 0, and it should still maintain accuracy. Um, but other than that, I mean, if there's damage to the diaphragm seals, no, I don't think you can actually repair it.
All right. And Hardy, you said you
Okay.
were going to drop some links into the chat.
Yes, the blogs that I mentioned, the two blogs, and also the link for the brochure, I will drop into the chat. Correct.
Perfect. Go ahead and do that. And while you're doing that, I just want to
Okay.
thank everyone again for joining us today. You should be receiving an email with your attendance for today, along with a link to the recording. And within the next week, you should receive another email letting you know of our upcoming WIKA universities. We would love for you to attend that, and you can just follow the links on the email and get registered. And that's all I have while Hardy is giving us those links. If anyone else has any questions, please feel free just to drop them in the chat.
Okay, that was the first one. Thank you, everyone. I just dropped all the links. Okay, thank you.
Very good. Hardy, everyone
Okay,
came back. You had a lot of thank yous, a lot of great presentation. So very good. Thank you so much, Hardy. And as always, it was a pleasure. Thank you, everyone. And I hope you all have a great weekend.
thank you. Bye bye.